All right, so hello everybody. I'm Luis Sempe. I am part of the O3D team at AWS, and I want to talk a bit about Script Canvas. I know we've covered it before, but it's an interesting topic and there's a lot to cover, so I'll try to not go too fast, but I have a lot to go through. So, if you're not familiar, Script Canvas is a visual scripting environment to create games or simulations or whatever content you want to produce. It allows you to iterate very quickly, prototype complex behaviors visually. You don't need to know C++. You can just run it, use Script Canvas to basically use O3D in new and exciting ways. But I don't want to talk about that too much because last year we covered a bit how to use it for control and movement, creating a lot of behaviors, covered how to make an animated sprite, use like overriding materials to use sprite sheets. So pretty cool stuff. Even earlier this week, if you were here, I talked a bit about how we can use it to create procedural content. What I want to talk about today is how can we extend Script Canvas for your own custom games or simulations or other products. So it's going to get a bit technical. All the content you see today is on GitHub on my fork. You can go to these two links and get them. So let's get started. So the first thing we'll need is to create a gem. And now this is pretty straightforward with some scripts we have. I will not explain too much, but all the documentation is available so you can just access it. So we create a gem, called a gameplay gem. Something that's new with the 22.01 release that just went out is the ability to create a Script Canvas library of nodes from a template. Here's the command line. It might look a bit cryptic, but it's pretty straightforward. You just tell it which template you want to use, where do you want it to go, and we'll replace the name of the gem that you created with, you'll replace the gem name with the gem that you just created, and this will allow it to produce all the code you need. So it's never been easier to create Script Canvas nodes till now. One last thing we need to do is to register the library so that when we build the engine, it knows where to find it. And then we'll enable the gem. You can do it through a command line, or you can use the project manager and just go and enable the gem that we just created. And now we configure Open Visual Studio, build. This might take some time, that's why we're not doing it live. But once you build all this, these are the three key things that we're going to look at. We'll have a generated Script Canvas notable XML file. This will be the node definition. It'll have all the topography of your node, and we'll go into detail. And it'll generate a header and a CPP file that will be pre-configured for you to start focusing on the fun part, which is developing your node and not writing all the boilerplate. So if we look back, I can show you Visual Studio real quick. This is a node definition that I've configured for this example, but we will have pre-generated it for you. Sorry, let me go here. I actually have what it looks like. There we go. So this is what we'll generate for you out of the box. And this will produce a node that looks like that. So the moment you create your library of nodes, you will already have this. From here, you can start working on just extending it for your use case. So the question is, could we make a full game within a single Script Canvas node? And so to prove that, I kind of did that. So I made this simple game. It's just, oops, let me run it again. It's this little target capture thing. Anytime you collect one of these gems, you score. And then once you complete, we go to a second wave, and then it goes faster. We change some parameters. The radius of movement is tighter, and we even move faster. So all this was done. Let me go back to the presentation. Sorry. I'll come back to these. I guess I should have put a slide where we showed it, but all that you saw happens within this one node. So we use C++ behind the scenes, but we expose a single node that then your content creators, your game designers can go in, drop this node, configure it in exciting ways, tune parameters on it and be able to just have a more fluid game. So let me go back a bit. So how do we do that? Okay, so we take that node definition that I mentioned, the XML file, and this, if you've been to the multiplayer presentations, this might seem familiar. We're using the same subsystem, which is the AZ AutoGen system that takes this XML code and makes C++ code for you. So we're going to start modifying this code. The first thing I'll add is a start input, and that just gives me the start execution slot. And we set it up with some, the description becomes a tooltip. So pretty simple. From there, we can start adding things like an input. And this becomes similarly another input that's execution, that's logic. But also we're adding a parameter to it, the straight value, and this is of type float. And that gives us a slot that is a value that we can modify. We could assign variables to it. It gives us that flexibility. You can almost think of it like if you're defining a function which you can invoke, and you're giving it some data for it to invoke. So then from there, we keep iterating on this. So this is what it looks like as a whole, but we'll zoom in a bit. So I'll add a new input for this particular game called start, and I'll parameterize it with a radius, speed, how many enemies in a given wave, and how quickly I want them to spawn. And then we'll have a move input event. This is just so we can pass in the fact that there's movement and what those parameters, what the value of the movement is, so we can do stuff in C++ with it. I will also add a prefab. This allows me to each wave to swap the prefab, and we saw it when I switched from a blue target to a green target, it was me switching this prefab. And also the enemy prefabs, even though I only used that gem, we could have changed it to be other prefabs. So it could have been enemies, it could have been missiles, you name it. And finally, we'll go to the outputs. This is the right side of the node. These are events that are happening inside the game that we created, so that content creators, game designers can go in and add scoring, maybe add some particle effects, sound effects, just plugging things that happen as a result of anything interesting that might have happened within that gameplay. So we talked about this. So now this is what the whole node looks like. On the left side, you see that we have the start and all these parameters and the input value that we're going to pass in, and all the events that will happen as a result on the right side of this node. What's interesting about this node is because we are encapsulating gameplay inside it, it's actually a state. And we'll look at it once we see the graph, the full graph of the game, how it's pretty much like a state machine that you could generalize into a more complex system for your own games. So this is now the C++ that you would write. Once we call the start function on your node, you get to write some code, and what we do first is we spawn the player. And you could do this within script canvas. You could go on and create a spawn ticket like we do here. If we have a player prefab asset, we create a spawn ticket. We track that ticket, so I keep a cache of those tickets so that later I can despawn. And then I invoke the spawn function, and this will spawn the little target circle that we saw. And then on spawn, once my entity, my prefab has spawned, and I know that it's the player, I want to do some additional setup. I'm going to add a new component onto this prefab. So I'm dynamically creating a component, and I'm adding it to this entity within the prefab. And the controller is going to, that component is going to be a controller that will define the movement. So we'll look at it in a moment. So what does the player component do? It'll manage the player inputs, so it connects to that input bus so that we can handle the keyboard strokes or gamepad or touch, whichever things we define. It'll update the player state and position, so it'll control that the target moves in a circle motion. And it'll handle also the collisions with the other prefabs. One thing I wanted to call out, when we spawn the prefab, this is a construction of the prefab that we have. It looks like it's a hard-coded player entity because of the order in which the entities are organized within the prefab. So it uses a level order traversal, so you can see that The entity 0 is a container entity of the prefab. Entity 1 is our player, 2 camera, 3 is the enemy spawn, and then when we go to the next level, I have a light in there just for visuals, and that's 4. So in this case, we know that the player is at 1, so I was able to grab it back here in the code so that I can create that player controller and install it on that first entity. Back. All right, so now the events, what happens on the right side of the node. When we define in our node definition events, we get automatically generated code that allows us to call, to invoke a function that's called call and the name of your event. So we can call on player spawn, on player moved, and any others that we define. And we'll look at that in a moment when we see the full graph. Similarly, we have the enemy spawner. This is what actually spawns the wave of enemies that you saw, those gems that are flying towards the player. It uses the same mechanism. When we spawn an enemy, we'll insert a component that is an enemy controller. And basically, that one's very simple. All it does is travel in the direction of the player in some randomized fashion, and it'll notify you when the wave is complete. So once there are no more enemies, it'll let you know. And this code will look familiar. Once we spawn the enemy, I dynamically create a spawner, which is not a component, that's just a utility class, but we will, on spawn, add a enemy controller component. And what's interesting about that is that you are encapsulating all these behaviors within this one node in a graph, which allows you to then go to the canvas and create complex situations in which, in this example, it's kind of hard-coded, but let me zoom in a bit. We get from the input handler the value of our strafe, which is literally, the only 2 keys in this game is A and D to move left or right. So once we get the value, we pass it into the node, and then we say start when we connect it. And from that moment on, the gameplay happens within the script canvas gameplay node. I hard-coded some values, a radius of 4, speed of 5, 4 enemies, and the enemy spawn speed of 0.5, so fairly slow. I can run the game in a moment again, and we'll see that in action. And then the other interesting part is on the events, when there's an enemy contact, I am sending a script event called onScore to be able to update that HUD with a new value. And once the wave is complete, I draw the text on screen that says wave complete, and then I start a new script canvas gameplay node, which just restarts the same game, but with different parameters. So now you have a smaller radius, you have more enemies, the enemies move faster, so you can see how you can easily change these behaviors. So I can run the game again real quickly, and you can see that. So the first wave, we move a bit slowly, the enemies move slowly. Anytime we capture one, that's a script event telling the UI, hey, update the score. And now that we've finished the wave, we've replaced the player prefab, we've tightened the circle, we've increased speeds, so it can become more challenging. So you can use this for any number of use cases, games, simple games to complex games in which maybe you're changing AI parameters, you're changing character controllers, combat schemes, many things like that. So that, okay. So now what we can do is we can even go and create a more infinite use case in which through parameters and some clever looping, we can just procedurally increment that difficulty every time. Oops. It's a bit hard to see because it's a bit far. In fact, I could probably just go to the graph. Let me open that one real quick. That's a bit easier to see, hope. So we only use the same node, the same setup. So when we start the graph, we handle input, we call the one node, but now everything's parameterized. And every time you complete a wave, we'll increase the speed. We'll set that, we'll assign it back to the speed. So every wave, it'll get faster. And then we'll use some random number to adjust the radius of movement of that target. and then just add it, and also randomize the number of enemies by some amount, and then we just go back and call the node again. So now we have this infinite game, which will just continuously get more difficult and continuously just add more enemies or randomize some parameter, and that's it. I even have a stray node. Very, very simple. And so the point I'm trying to make with this is that script is great. You can use it out of the box for many things. And everything that we did today can be done just with like an expanded script graph in which that one node is an actual graph. It's complex. It has all those behaviors of spawning, creating a spawn ticket, tracking all these things. But by encapsulating this way, I mentioned it earlier, we've essentially created a state machine. So if you can see that you can take this concept and apply it to many games, one of these states could be in a complex game that has player interactions with objects. Perhaps the state is the character using a vending machine in your world or interacting with another NPC. So you can do very, very atomic operations or complex operations and chain them together and create very, very cool behaviors. How are we doing on time? Okay. There's a little bit more that I want to talk about that we've released with the 2201 release, and that is the ability to create function libraries. We take the same autogen paradigm that we created, and we use it to simplify the process of exposing simple functions to script canvas. This is very useful for things like math. In this example, it's basically like an absolute value cross product, a direction function. And the way we do it is you define these functions in an XML file, pretty much like the one we used to define the node earlier. And you can have any number of them. And then you give them the body of the C++ function. And then script canvas, well, the code's going to understand what you wanted and generate those nodes for you. So we've simplified it vastly, the process of bringing your functionality in. This is all documented in our docs, and those docs have been recently updated to reflect a lot of these functionalities. So yeah, some of the key takeaways I want you to know is that everything that we did today, you could have done without C++. We could have just used script canvas out of the box, and we could have done all of that. But we brought it into C++ because we can control certain elements and provide very customized nodes to our teams, to our content creators, to our game designers that remove some of the uncertainty or the difficulty in maintaining a script canvas graph and provide some kind of guardrails. You provide a node that does a lot of things in C++. It's going to be more efficient. It's going to have exactly those inputs and outputs that you want people to use. And so you might find fewer bugs or fewer logic mistakes along the way. Script canvas nodes can be stateless, like the functions that I just showed you, meaning that you call them, they execute some behavior, and you get your result. Or they can be stateful, which means we can actually bind them to the tick bus internally, connect to a tick, have the node do something, like in our case, a game loop, and then when it's done executing, you can disconnect from a tick bus and then continue on forward with the execution. The new simplified way to expose C++ functions, this is super, super useful. It just accelerates when you have a content creator or designer who says, hey, we don't have this math function, I want to target a camera to a certain position. You're like, no worries, I can just add a function, compile it, submit a pull request, and off you go. You have a node that will do what you need. And finally, the engineers can extend script canvas with custom behaviors. It's very extensible, and I highly encourage teams to start thinking along those lines. It's not required that script canvas be used out of the box. It's, in fact, a fairly low-level way of doing things, but you can create more specializations of nodes that do what you want them to do and just deliver those to your teams. And yeah, that's about it. I don't know how I'm doing in time, but if you have any questions, I'm happy to answer. Thank you. We'll bring the mic.
Hey, so thanks for the talk. I haven't used script canvas really before, but I guess my main question is sometimes there's behavior that you can like write in two different versions. You could, for instance, put it into a script canvas node, or you could put it into a component. And do you have like a good guideline how to distinguish which one to use in which scenario, right? Because so, for instance, we have like we've made like this eye shader, and we have a look at component that it's like this. Basically, attach it to an empty entity. It's not really meant to show you anything. It's supposed to guide a bunch of eyes to look at the same spot. But I guess that we could have encoded that as a script canvas node as well.
So anything you expose on a component, you can very easily reflect it to the behavior context, and then you get the functionality both ways. So that's my recommendation, is to do it both ways. Anything you put on components, it's functionality that you may want to script, or you may want somebody to script. If it's only on the component, you will be limited to maybe saying like, hey, I want you to look at, and then you have to specify which other entity. But on a script, that entity could be dynamic. It could be the result of some operation. It could be passed in by an event saying like, oh, when this enemy spawns, look at the new spawned entity, not the one you were looking at before. So I would recommend exposing it to both as much as possible. Like anything you want people to customize should be scriptable.
And is there another consideration apart from the flexibility of script canvas that should be taken into account, like for instance speed or?
So when you reflect to the behavior context, that makes what you reflected available in both Lua and script canvas. Script canvas, when it's processed, it's actually outputting Lua code. So it's going to be as performant as any Lua script. Of course, if you want like absolute speed, you will probably want to put most of it in a C++ function, but you can see that you can call them or expose them through nodes so that they're still executing C++, except you have a way for someone to invoke it. So.
Okay, cool, thanks.
Yeah, I think there was a...
Just a few thoughts on the previous question. Personally, how I would do that is I would ask myself whether I need customization on this new functionality or component that I add, so that I can put it in a node and define custom behavior in certain scenarios, or make it easy for like other users like tech artists to plug this node in various scenarios. Whereas if your component does something really simple, like let's say on collision, you just want to have a blast effect shown or leave a decal, I don't think there's a lot of customizations you would need there. So maybe that is how I would probably prefer to decide whether to put this in a node or in a component, depending on how customizable do I want this. But that's just my opinion. My question is regarding versioning. So as like one of the key contributors or architects of script canvas, so how would you recommend that authors of custom script canvas nodes handle versioning? So if I create a custom node, it is very likely that it changes across O3D releases, and being backwards compatible is like a big issue, and it's very, very important, and it's something that we ran into recently. You can upgrade your scripts using a Python script, but I feel like there should be an easier way to probably do that. So are custom serializers the solution, or do you think there's a better solution out there? Yeah,
so we completely agree. One of the things that is in development now, there's a pull request out, or it might have been merged by now. It's a mechanism using the settings registry files in which we can replace nodes. We can deprecate a node. Let's say that my gameplay node that I created today, I want to change it, but we already used it in many places. So through the settings registry, I can say, okay, I'll take the ID of that node that I created, and I want you to replace it with this other ID. And then when you open the graph again, ScriptCanvas is going to do its best to leave it in the same shape that it found it. So it's going to try to recreate all the connections. If there's slots that have not changed, they will be reconnected as they were. In some cases, it's not possible because if you remove the slot, then we just remove the connection, and you will have to do some manual work to fix it. So we are taking some steps to make that easier. There's opportunity, there's abilities already through version converters that we use through a serialization context. They're a bit complex to write, so we want people to write them when they're necessary, but we understand that they're so complex to write that most people don't, so we're trying to move towards easier methods to do that. So the method that I described earlier is the one that we have in progress, and we have other ideas also on how to make versioning possible.
Okay, thank you.
Yeah.
Hello,
Hi.
my name's Lee. I'm the UX designer at AWS. I was watching a talk earlier where Chris and Mike presented about interactive tutorials. And since ScriptCanvas is a fantastic way for someone that doesn't have too many programming skills can actually utilize the engine, have you had any thoughts about collaborating and working with the interactive tutorials team?
Absolutely. We welcome collaboration. We're eager to get more folks involved into extending ScriptCanvas itself, creating more nodes for everyone to use, and taking advantage of things like the interactive tutorials. It should be doable. I don't see any reason why we couldn't do it. It just needs someone to jump in and start working on it.
Definitely. Thank you.
Yeah, thanks. Good question. Let's put Chris on the spot.
Any questions? Any other questions?
Okay, so no more questions. I think we can call it. So thank you, everybody. Really appreciate it. And like I said, we look forward to more collaborations. So if anyone's interested, just jump on Discord. We can talk about scripting a lot. It's super fun.